Welcome to another Confluence podcast. I'm Randall Stevens, and as usual, I have my sidekick, Evan Troxel, or I'm his sidekick, is probably the reality of this. Uh, was at AU last week and had a lot of people. I had somebody were like, they were standing there like, I know your voice because I listen to that podcast all the time.
Wow.
We're
Nice.
starting to get a few people listen, but we've
Excellent.
got a very special guest with us today. He's kicking off our third season. It's Matt Anderle from AECOM. So Matt is he's been at AECOM a while. I'll let him tell you more about what his role is there. But I'll just tell the quick story that when I first, and we've become friends so over the last few years. But when I first met Matt, like in 2016 probably or 17, we had started those building content summits. It may have even been before that, 15 or 16 time frame. And it was the early stages. We're working on a veil. It's going to be this content management, including stuff for Revit. And I was telling somebody this story last week that I'd never met Matt, and he's there at this building content summit. So I walk up and introduce myself, and I was like, we're working on this like content stuff. And he's like, yeah, I manage a little content and around Revit. And I wasn't even really aware of AECOM, right? Been spent most of my time kind of in the architecture world, and that wasn't even named. He's like, I'm like, yeah, how many seats would you be good for? Oh, I manage about 15,000 seats of people with Revit, and I'm like, oh, wait a minute, maybe
Just a couple.
somebody I need to know. But anyway, just kind of a funny story
Yeah.
that Matt was like, he's a smart guy, very humble, but he does some really amazing stuff. So it's going to be a fun conversation. Matt, why don't you just tell us a little bit more about what your official role is, and then we'll dig in.
Oh, what else could I add to that, Randall? That was a great introduction. Um, so the official title is Director of Digital Strategy, and I work with our teams all over the world to try to advance how we deliver advanced types of methodologies for projects, and extends all the way up into digital twins now. So we can officially put that as part of our repertoire and skill sets. In addition to that, always trying to advance our practice and move forward, I run a robotics team, and we use that to complement the tools that we use on an everyday basis for reality capture. So trying to advance the needle forward. Been with AECOM for over 13 years now, and loved every minute of it.
Can you just give us kind of an idea of where AECOM is currently? Because Randall gave the story of 10 plus years ago. Where's it gone in the last 10 years?
Well, so we've evolved, of course. We've moved beyond the we need to develop better standards into we need to deliver more intelligent models, and that really leads us into that digital twin component. And I have a high bar for digital twins. If anybody asks me, I'm going to tell them that it needs to be an operational model. It has to have
Mm.
live connectivity into the field. Otherwise, it's just a really great existing conditions model, right? Which has value, but I think that digital twin is an operational complement to what we're already using for the asset management world.
Very cool.
So I had said that this season I wanted to do a couple, and Matt was the first. This is the first kind of guinea pig episode where I wanted to do a crib style. So I actually went up. Matt, I'm in Kentucky in Lexington. Matt's about 3.5 hour drive north of me in Columbus, Ohio. And I've been up there a couple of times before. He's got this great office and workshop. It's like going to Santa's workshop to go up to Matt's place because he's building all the robotics, and we'll talk a little bit. But I did go up and we shot some footage, which we're going to integrate into this episode as we talk about the different kinds of things that Matt and his team are doing. But part of it is his official role at AECOM is they're building, you know, robots basically that they can send in for scanning and reality capture of those kinds of things. So maybe Matt, you can start there, and we can dive backwards into from the Revit side of things, but maybe you can just talk about what you all are doing on the robotics side, and then we'll lead this into how you got there and some of your hobbies and what you're doing on that front.
Sure. Yeah, absolutely. A lot of what we developed so far has come out of the necessity, right? We've got these projects that introduce challenges to people and in the environmental conditions that we would be exposed to are a risk factor. And simply maneuvering 20 or 30 pounds worth of scanning equipment around some of these spaces is of concern for our staff, and doing that in a very hot and humid environment, and then trying to navigate low clearances and other kind of obstructions like that are just difficult, right? And if you're doing that all day every day for a month or so, it becomes taxing on our staff. And so, using some of my hobbies and skill sets and experience in the past, some of the kind of microfabrication type of stuff that I do, it became evident that we could make something that could improve our process. And so, in doing so, we developed these rovers that essentially are tow vehicles for LiDAR scanning equipment. And on top of that, we have sensors that are built into them, so we get more information from that activity on site and can compare that now to the different spaces that we scanned, and bring some additional metrics back to our clients who are asking it to get into these spaces and bring that kind of level of information back that otherwise wouldn't really be obtainable in any easy mechanism for humans to approach. And we get to a point where we're in scenarios like sub-basements of buildings that are 70 years old. And if you can imagine, 70 years ago, we didn't have internet, and we didn't have a lot of the kind of the power demands and other communication demands that we have now. So approaching a building of that structure, of that age, the sub-basements are 4 feet tall. They have dirt floors, kind of muddy floors at this point because of the environmental scenarios that exist there. And anywhere they could add new infrastructure, they ran it however they could run it. And so there's not a consideration for serviceability or accessibility for humans in that space. It's just a very narrow and tight space to begin with. And then you add a layer of evolution in the ways that we use those buildings over time. It adds a layer of complexity. So in that scenario, one of the first things that we observed is in some spaces there's 14 inches of clearance, and that's between the mud and the pipe. And so to be able to maneuver below that or around that is a very complicated task. And doing that on top of carrying very highly sensitive equipment like laser scanners would be almost unapproachable. So the robotics program really spawned from the challenge in front of us, and it was something that our teams had done in the past. It's not ideal, but it's something that we could improve upon. And as we looked at the ways that we would capture the information, we also looked at the ways that the rovers would interact with the devices itself. So carrying battery packs for the devices, carrying communication with the devices, be able to extend the range of our human staff now. We could send rovers out into these spaces to cover 100,000 square feet, and then bring those back to where we had our staff situated at a safe location. And then looking at what we could do, now we have a rover, right, that can move around. It's got a computer on board. We can collect a very high level of data set that comes back with the LiDAR cloud. And as we stop and capture positions, now we're capturing environmental considerations. So what kind of humidity is in that space, what kind of temperature is in that space, looking at if there's any dust or particle kind of intrusion, so if there are any air qualities that we need to be concerned about. All of that now is a data layer set that's on top of the point cloud, which is otherwise just data, right? And now when you pair those things together, you start to look at what is the condition of this area. Do I have hot spots? Do I have very humid spots? And why? Is there a leak, or is there steam? Is there things that are kind of being absorbed into that location that shouldn't be there or could be rectified, so that there's a higher operating level of service that comes through the building itself. And that evolved into, I think we have 7 different vehicles now, working on our 8th. And it's everything from that kind of tow vehicle, high data collection rover, up to we've got like a pipe crawler that's really meant to go into a very small diameter pipe and navigate through in a singular direction, and then come back and capture high resolution video, spherical video, the same environmental considerations that we're looking to collect, and go into areas that people don't fit, first of all, and then go into areas where we have that high risk, where we're traveling 1,000 feet down a storm sewer, and the access points are 1,500 feet or 2,000 feet apart. In addition, we do some aquatic vehicles, so we're looking at at scanning underneath like bridge structures, looking at basements. We have cameras that go below water. We've got bathymatic sensors that will go down and actually scan the terrain. So we have now a capacity to bring a vehicle into a situation where we're traveling up and down through a river or under structures that would be hard to get a human being into, and we could do so remotely safely from the shore. We try to introduce the same kinds of data collection that we have in our rovers within any of our vehicles. So as we're trying to travel through the water and get into the spaces, we can actually kind of track current and how far, how fast we're moving and how far we've gone, where we might find those kind of subsurface obstructions or other kind of debris or elements of awareness that we should know about. And water temperatures and air temperatures and trying to kind of discover what kinds of things are happening around the scenarios that we're doing this inspection.
It's pretty fascinating because I think about photography being like a moment in time, right? You see a photograph, it could be the absolute perfect conditions, but just by what it looks like, you're actually talking about painting the whole picture. And I can't tell you how many times I've taken a photograph and I'm like, no, people who look at this have no idea how hot it is or how windy it is or how cold it is or what it smells like or any of those things. And I think it's absolutely fascinating that you're trying to paint a picture of like, you're not just capturing the built environment into a point cloud, you're trying to capture these additional layers. I think that's just super cool. It's like, because like you said, like there's mud down there, so there's humidity or there's moisture intrusion or whatever, and you start to get a bigger sense of what's actually going on in these locations that, like you said, it's difficult to stick a person in there, let alone for how much coverage you're talking about and for the time period it would take to scan all that. I think it's pretty cool. Could you kind of give us an idea of just paint a picture of what these, for those who aren't going to get to see Randall's shots of these robots, like on the video, who for the listeners out there, can you just kind of explain what these rovers kind of look like, what size they are? I know you've got several of them, but
sure. They range from anything that is about 8 inches in diameter. And we have a little trike that has like a center articulated frame, so we can turn it on a center pivot and maneuver in a very tight space in a circle that's almost, I'd say 10 inches in diameter. But that allows us to go into anything like an 8-inch diameter pipe, or in some cases we have these narrow kind of channels of infrastructure like conduit piping and communication cables that go through a hole in the wall, literally, that travels the entire building or half the building. And so we've taken our trike and we ran it a couple hundred feet with high resolution video to observe where these conduit runs actually progress through that space and where they introduce and then leave in those same kind of scenarios. Anything from that size, so a very small vehicle, up to our largest, which is about 36 inches by 36 inches and has a capability to raise itself and lower itself, to carry a scanner on top of its back and really maneuver through a space and get to the lowest point it possibly can while still moving a scanner, and then kind of navigate over debris or obstacles that are in front of it. Our go-to, though, is our package we call Scout, and it's about the size of a pizza box. And it's got, very large kind of balloony paddle tires on it. So when we get to that muddy scenario, we can dig in and maneuver through that space. It's also when we have our tow package on, where we can add extra batteries, add those LiDAR scanners to it. And is the most versatile because we can take it into the storm sewers, we can take it into muddy basements, we can take it into fields and use it kind of likewise across all those different scenarios. Same with our aquatic. So our aquatic platforms also are about the size of a pizza box, up to about 36 inches by 36 inches square. And we'd use like a dual pontoon scenario where we've got a couple different drive mechanisms, so differential drive within 2 props. And then in the center, we have an array of frameworks that we can attach all kinds of different sensors to. And our goals really in this whole platform we call Markup, which stands for Mobile Autonomous Reality Capture Utility Platform. Our whole goal here is to be versatile. And so we use this kind of structural framing mechanism to be able to slide and arrange and to change or augment those vehicles to address any kind of scenarios that we're going to go into. One of the jokes that we have is we'd like to deploy our rover with the same configuration twice, right? And we get to all these different locations and different types of activities that we have in the field that we have to mount more sensors. We've attached double cameras, 3 cameras, different type of sensors, different lighting packages to it, to be able to get the best results possible within an ever changing kind of infrastructure environment we have to approach.
You brought one of those platforms to Confluence a couple of years ago and showed it off. Was it the?
I did. That was Scout. Yep.
Yeah, that was it. That was the size. Yeah. Um, I was just going to comment a couple of things that struck me. One, you do tether so that if because you're sending this thing off into the hinterlands underneath these buildings, but you do have a safety tether so that if it ever gets stuck or something, you can pull it back out. I thought that was interesting. Cable. How far can you reach remotely, or how far off can these devices go?
That's a good question. So our tether is not traditional. Most of these companies you see they're doing inspection with rovers are communication tether and power tethers. Ours is strictly for safety, and if everything on our rover is battery operated. Everything is remote controlled wirelessly, so we're commanding things on the rover, and it's taking action from what our wireless commands are sending. Theoretically, our equipment can go up to a mile plus, and it's something that we've never had to challenge yet, but we've kind of tested out to a good plus 1,000 feet range and had full control. So it's certainly capable of extending beyond what our challenges have been on projects in the sites. But the uniqueness is if we had to disconnect the tether, we could. So we could actually run the rover all the way through, let's say, a storm sewer, collect it at the other end, and bring it up through, and or reconnect and then continue down even further. But because we're completely wireless, if we had to, we could disconnect the tether altogether and just run it completely remote all the way through an environment.
So is it streaming video back to you the
It
whole
is.
time?
Mhm.
So I would imagine you kind of need to see what it's seeing at some level.
Absolutely. So we have long range first person view cameras like you'd have on drones. And we have screens that we watch, but we can put goggles on and watch that way as well. And through a gimbal, so we have a kind of a camera on the front that uses a gimbal to look around, gives us full optics on where we are in the scenario within that environment, and can use it to drive forward or turn around and drive backwards with it. So it gives us a lot of versatility of understanding where we are in the position with this remotely. But in addition to that, we have cameras that are capturing 8K resolution 360 video at the same time. And we compare that with the data. We compare that with the point clouds. So a lot of sensors that are built into this, called a sensorium of information. And it's something that we're in a mission. We're trying to really collect as much as possible and then use that as a means to kind of evaluate visually or translate that into any type of actions that have to happen within the client's expectations or what the scenario is on site.
One of the things, Evan, that I thought was really cool, maybe other people do this, but Matt's designed these with the battery packs are like standard batteries that you would use like a DeWalt or on a.
Oh, okay.
So it's like, he was
Cordless tool
yeah, it's
batteries.
like, okay, if we're out and we need an extra battery or something, need a part, you can just run down to the hardware store and grab extra batteries. So I thought that
Very
was
cool.
pretty smart of you. The other thing I was going to say when you were talking about the links, and I'm pretty sure we've got some footage here that we'll be able to show of this, but they've created a arm that can be attached to the rover, and it will actually take fiducials that are on a magnet and stick them to the pipe above, so that they can then go further, and then they can use that for calibrating, across longer
Okay.
distances. So
Like a registration point.
yeah,
Exactly. Yeah.
they've actually created the fiducials with the magnet on it, and the arm will get one off the end of it and stick it on as it goes down its mission. So it's pretty cool.
And that was a
Yeah.
challenge because we had this project to scan a culvert and to determine if there was any sort of kind of soil penetration or deformation of that pipe over time, which we actually did discover some within our scans. But to laser scan a smooth pipe, you have no registration points. And so we went 500 feet down 2 of these that are parallel to each other. And because there was no registration points, we made this 4-axis mechanical arm to take these targets off of a carriage and lift them up and magnetically connect them to the top of this steel pipe. And after we
Wow.
did that mission, came back, dropped off the arm, put on the scanner, and then went through and scanned the 500 feet and had I want to say perfect registration, but we had registration points throughout the entire pipe from start to finish, and then targets on either end, so we can use that for referencing.
How would this have been accomplished before you had these devices that you've built? How was it possible to do? More expensive? Are you cutting time? Are you
The
improving?
biggest thing is mitigating risk to our staff. And you could have somebody who's confined space trained, who's crawling through these pipes, likely on hands and knees kind of
Yeah,
approach,
yeah.
right? Have some sort of surface to sit on because there's water running through them, of course, and then setting up tripods over and over and over again and trying to mark targets themselves. So they'd have to navigate through and actually set targets and then go through again with a scanner to scan the infrastructure. With the rovers, we can sit back at the opening of that area, run these through with the video feedback, and while we're doing this, we're also getting the video capture, set the targets, come back, run the scanners, and then go back to the office and have a data package collected safely and more extensively than somebody could as a person.
Yeah, I think you were telling me about a project, maybe it was earlier this year, where you all were an old hospital, if I remember right, in the
Yeah,
Midwest, and you all were
the
just along,
ODBs, right? The old dirty
right,
basements.
yeah, confined spaces, lots of, everybody's been in those steam, hot,
Yep.
humid, terrible conditions, and for you all to be able to deploy these and get the data you needed for planning. So yeah, there's probably obviously more and more buildings like that that need these kind of, can use these kind of capabilities to help scan. Um,
Certainly uncomfortable conditions.
yeah, yeah. No, I'm with you. I want to be sitting out there with a remote control
Yeah,
and sit out there where it's a little more comfortable as
very
you're
true.
sending this data in. Let's talk a little bit about just how you got into building the robotics. I was telling Evan earlier, it's like when you go up to your shop, it's like going to Santa's workshop. You've got, you know, 3D printing capabilities, but
Yeah.
uh, tell us about your hobbies and how that led to your being able to tie that into your profession.
Yeah, absolutely. So I've been into just models for my entire life, right? All the way from kids up till now. There's no difference. As my interest has grown, so has my use or um, kind of pursuits of those different hobbies has evolved. 3D printing's opened a lot of stuff for us, and if you're I call it micro manufacturing, but if you're a rapid prototyper, micro manufacturing, enthusiast, you're going to have 3D printers and make stuff. And the first thing you make is, I need a fix for a part, right? And I broke something in my house, I can
Mhm.
3D print it now. Um, Applying that to RC, in cars and trucks and boats and planes, you name it, you start to modify, right? So I'm creating custom parts, and that eventually evolves into, I bet you could just build a brand new thing and start from scratch. So all of our design software kind of yields to the creative, and whether you're making buildings or you're making parts, it's all that kind of inspired process, ways to make something out of nothing. And uh, and then I got into robotics. So I took computer programming as a minor in college, and now I'm pairing making stuff with programming stuff, and it does stuff when I'm done. So that's really how kind of robotics has been introduced into my passion, and now it's part of my job.
When you're building the robots that you're using as part of the DPT team, are you making everything, including the software? How much of it's already gave away that the batteries, you're going and buying those, but almost everything else you're actually building yourself. Is that correct?
So the frames, the tires, anything that's a product of other interests in the industry, is something that we would purchase. But all the customization, so anything that is unique outside of extruded aluminum, wheels, and motors, all of that is something that we self-develop, and even gone as far as developing our own circuit boards to run these machines. We still have microcontrollers that are available, like Arduinos and Pi and things like that, but um, we plug those into our own circuitry components that actually control the rovers and give us some instruction forward and backwards through that. It's unique in that we have a lot of control, and there's a lot of burden in trying to do that yourself. A lot of discovery, right? We're trying to discover things, how to do them better, or how to improve the efficiencies of what that device is kind kind of receiving, processing, and how it's performing. But it's rewarding that we can make any kind of augmentation that we need almost instantly. And if we need to program in new sensors and new controls, new data collection, we can usually turn that around within a few hours, few days, instead of trying to find a solution, introduce that, and then try to plug that in.
I'm curious, like on the robotics side of things, have you gone as far as finding robotics specialists to bring into roles inside of AECOM? Like architecture firms, 10, 15 years ago didn't have a data analysts, right? They didn't have developers developing software, for example. I mean, and now we're hearing about like the work that you're doing with robotics. Is that something that you hire specifically for in the business, or is this something that you've just completely taken on yourself
It is,
because of your?
and we've had a couple team members in our group that are passionate about this industry, like I am. So we've actually hired, and some of the traits that we've hired are people who are really in tune with this kind of hobby, the RC hobby or the micro manufacturing side of things.
Cool.
Our latest hire is somebody who's done CNC and welding and those kind of traits outside of their passion for BIM. And so that kind of skill set of that person being an artist and having that kind of just passion outside of work and being involved with that on a regular basis, they bring those skill sets to the team. My entire team, I can arguably say, is somebody who's either passionate about the design side, the fabrication side, the programming side, or the operator side. And all of us are either like a Part 107 pilot or a pilot in the rover world because they've been in RC, or somebody who's more on the aquatic side, does boating regularly, so can kind of help navigate currents and drive our aquatic vehicles in different scenarios. All of those have skills that apply into just the task of reality capture. And I hate to diminish what we're doing, but they're tools for us, right? They're just like a LiDAR scanner. We use this to go and collect data and come back, and that's something that extends our services. So, Rand, I know you mentioned DPT, stands for Digital Practice and Technology, right? It's a subgroup within AECOM that is kind of that high-level delivery team looking to kind of advance BIM and SIM and asset management, but we're also on the reality capture side. And so our rovers become these tools that extend our capabilities into places where either people can't go or shouldn't go or don't want to go. And so we're also trying to evolve our team and grow our team in that same capacity where even this last summer we had two interns. One is a mechanical engineer who is participating in some of the engineering design, and we're looking at a new candidate for an apprenticeship that is also in robotics and can complement the team for programming.
Can you talk about tools that have kind of evolved in this realm for you over the last 10 years? Because I've seen some incredible stuff from like Disney. You see the swinging Spider-Man that lets go of the web and does backflips and stuff. And then they've even shown off stuff at their conferences that they've been working on. I assume, obviously advances also have to do with the tooling, not just kind of like the iterative process of building robotics and testing and seeing what happens. But I would imagine AI, for example, with coding and things like that, has kind of changed the game when it comes to what you guys have found your capabilities to be able to pull off. So, like, what else has in that realm has really helped open this up in a bigger way than you probably ever thought was possible?
I think every aspect of it, from start of design, right? Our tools that we have for analysis of design, doing some physics and load testing, generative design in that respect, helps us to better understand before we actually fabricate something. And then as we get into fabrication, all the tools that build stuff now are better, right? We have more precise CNC machines that are more approachable. We've got faster printers, like 10 times faster printers, which is immense when we're talking about a part that takes 36 hours to print versus 7 or 8 hours to print. And so our design source to introduction into our rovers now is something that we could do in a day instead of a week. And so just being able to rapid prototype something, test it out, work on the effects of that within the rover platform and how it improves or challenges the rover essentially is something that we can be more immediate about and turn around kind of designs and augmentations faster. In the same regard, we couldn't process all this data without AI, right? We have to use a very high level of computation to be able to just read point clouds and process those, let alone from the data set that we're collecting about the environment on top of it. and we infuse those together. So what we're trying to do is bring that environmental information into the cloud and understand, and I mean point cloud, bring those things together so you understand this kind of wealth of information every time that we stop, grab a position's information, and capture what exists there. So the tools to build what we make, and the things that we use to program and evaluate the data, and then the scanners themselves are more efficient and higher resolution, and they're getting smaller, right? The new scanners that are coming out are starting to achieve the same resolution that we had 10 years ago, and something that was 10 times the size. And now we can put that on top of a rover and be able to get into smaller spaces with a scanner and be more versatile, run longer, go further, and still get a similar data set back.
Much of the materials changing, Matt, with what you're able to print, or are you?
There's a lot of advancements in materials. Yeah, these printers now can have carbon fiber infused plastics and polymers. That's something that didn't exist in the industry, 5 years ago, maybe even 3 years ago.
Which
So
lets you get smaller and smaller, stronger and stronger, smaller and smaller. Yeah.
exactly, and you're getting more of that professional industry engineering application of material in your printer head. And it's something that you can actually build a part that's actually structurally sound, comparable to something if you CNC'd it or created out of another material, that used a longer, much more enduring kind of application. So the printers themselves, the higher resolution or the higher heat outputs, the materiality of that filament, or if we're using resin, the resin material that we have, all of those are advancing technologies that help our types of industries let us build two things, and it doesn't cost us $1 million.
Evan, you're going to see in some of these images and photos I took, but when we probably all had something RC. When Matt says he's into RC, you've got to. It is planes, trains, automobiles, hundreds.
Nice.
The model train collections, them just alone, are incredible. Matt, what are the different scales of
So
trains
I'm
that you?
I'm almost exclusively N scale,
It's
which is
almost
like
all
the
in
1 to
scale.
160 range,
Yeah, and
right?
it's cool because he's obviously got the trains themselves, but he's building the dioramas and there's a
Mhm.
certain module size. So as part of the club, you can like build these and then bring other people. Everybody can bring them together, and that's how you build. So maybe Matt, you can give a plug for because I'm going to go down to Is it Chattanooga next summer?
Chattanooga, yeah.
Yeah,
The
tell
NMRA
everybody.
convention in
Maybe
26,
maybe
yeah.
we'll end up with a bunch of people descending on Chattanooga next summer for this.
Maybe, right? If this is a shout out for anybody, right? Go down to Chattanooga next summer. Um, End of July, early August, I think, is the convention. But they're going to set a world record, which is something that's not a small feat, and it's using a standard called T-Track, and these are a module that's about 12 inches across and 14 inches deep. It's a standard box. You put two tracks on the front, and then the rest of it is to your inspiration and design. And as long as you have the standard set, you can snap any number of them together, and it makes a large layout. So down in Chattanooga, they're going to set a world record for the number of modules that are connected together to make a layout, which is I forget how many miles of length that track's going to be, but it's an unprecedented event, and I have my own modules that are going down there and going to participate myself.
As well
Um,
as Matt was showing me that they've the controllers for the trains. He's got a couple of kits that he's kind of built. One smaller for testing, if you got your
mhm.
locomotive and you can test it to make sure that it's all set right before you. But he's got larger with antennas that open up that can control like what 50 locomotives at a time. So anyway, he's got a lot of really cool electronics and equipment that are used to do these very large, massive train layouts.
And uniquely yet similar, trains now are controlled by computers. And so if you've been out of the hobby for long enough, the old dial throttle that makes your train go forward faster is still available, right? And some people still use that. But for anybody in the kind of the modern era of this hobby, there it's all computer based, and it's all kind of floating ground signals over the tracks, and it tells the computer chips what to do. So every locomotive has a computer inside, and it reads the signal that's like a layer. If you ever did like Ethernet over your power lines, it's the same kind of effect where it's sending signals through the track, and then the locomotives
Wow.
read that and then determine if it's instruction for them or something else. And if it's for them, then they take action on what the instruction is. So you can have trains running in different directions. You can have 10 trains on the same track all running, at different speeds of each other. But it's really a data network over the track, and your locomotives are just one of the devices that sit on it.
It's interesting to think about kind of the crossover, even just with what I know about media and well, people who put together shows that go on network TV, for example, like an NFL game or something. They use a system called EVS, right? And it's just a play out. It's an order of events that happen over time. And I could imagine you having like a grand kind of playbook of everything that's going to happen, and it's sending those signals out, and like you said, some are picking up on them and some are just saying that one's not for me, but then it executes it at the right time in the right order, and you can orchestrate like this whole thing to happen. That sounds amazing.
We even built sensors into our modules too, so as trains approach, crossing gates will go down, or switches will throw, or we'll
Like
have things that
behaviors
will
automatically happen.
right.
Yeah.
And it's based on
Very
what
cool.
you can have it based on what locomotive is approaching, even, right? And have it, if it's this locomotive, throw this turnout and go into this stall or something like that. So
I thought it was pretty cool, Matt, that you were showing that your club, they get kids involved too. So that module they can do, they can let kids learn, and build their own part of their module. Each of them gets their own module to put in there. So I think it's just a great that you can bring young people, into that hobby, which ultimately translates into these great careers like what Matt's built for himself at AECOM with these kinds of technologies. So what a great gateway to getting more people involved.
Specifically about trains alone, I've ran fusion classes on how to model things. I've run landscaping classes, assembly classes, kind of that craftsmanship level. Talking about trains, talking about scale, right? You introduce kids to scale and what that means as far as sizing things from the real world down to the size of a module, right? And any of those become a passion for someone, right? You could be somebody who wants to get into art because of the way you're painting, or you're creating landscapes, or generating that kind of design on the module itself. Or if you're somebody who's more of the engineering, you want everything to be perfect and build things to scale and fabricate. Or if you want to get into trains and transportation and any kind of market sector that leads along the lines of how we maneuver through our environment, get into autonomous vehicles. You can get into the way we kind of automate transport, and when we get into this AI driven environment around us. All of those things start with some inspiration, and in our club is pretty good at the outreach to conduct some of these workshops with like Boy Scout clubs or with youth groups or schools, and get in front of them in that capacity. And if the kids show interest, we'll have 10 workshops, as many as they will allow us to participate. Our group is pretty open to doing so. And everything from the software side to the how do I cut things and make things at scale and build stuff.
I was just wondering if you could talk about that aspect of it versus like schools getting rid of programs like that. Because another big thing that's happened, we've seen over the last 10, 15 years, is maker spaces have popped up where they have a lot of these tools, and it doesn't make sense for everybody to own all these tools. It makes sense for like a community to own these tools that people then get to use. But also, like I said, like those programs have kind of disappeared from the typical education system. I would imagine that there's a huge draw, alone just because of that.
There is, and 3D printers are approachable, right? You can get them at local stores here, at least. Not everybody knows how to use them or how to get started with them. So what we've done is try to create kind of these curriculums that are inspiring for the kids to create something that they could finish in a workshop, maybe even start to 3D print or 3D print and have ready by the next time that workshop continues. And if we find that if we have something that turns into a tangible object or turns into a result, that really kind of kickstarts it. And then the pressure is to hold back, right? Now that you've got started, how do we slow down? But I think that you're right. There's some things that some schools have those opportunities and others don't. My family and my nephews and nieces have been in a school where they've had robotics programs in school. And so they have rapid prototyping, they have design, they have that engineering component. Others I know don't necessarily have all those things. So wherever we can, find that outreach, and in our industry, it's important to bring this skill set forward. Right, STEM is probably one of the greatest things that have happened in America and around the world. For us to participate at any scale is really helpful for us because that leads to more people in the design, engineering, and fabrication industry, and helps kind of support where we're growing as well. And as a company, we're seeing that coming out of school too. So individuals that we're hiring for internships are coming out of high school or coming out of college that have that kind of experience throughout their career in education and something they can apply to our teams.
Sign me up.
Yeah, I know. Sounds like fun. The we'll put some pictures and video up, but to describe, because one of the things he had built when you started talking about scale, you built a turbine that was at scale for the
Yeah.
train. But when you see how big the actual these windmill turbines are, but maybe you can describe what you built. I'll put up the pictures and video as you maybe
Yeah,
describe.
absolutely. So we always are trying to push the envelope, of course, of what we can make, and when we're sticking to a standard, right, the module like 12 by 14 kind of size, there's opportunity for you to make like a double size and a triple size version of that. Um, it's interesting that at the 1 to 160 scale, it's small enough where you can make some very large components like a wind turbine, and still have it in a transportable state. Otherwise, it would be feet tall. Um, it was important for me to challenge myself and get into that kind of micro level. A lot of our rovers that we're dealing with are kind of in that mid range, like I said, pizza box or trash can lid size. I want to get very small, so tiny geared motors, resin printing to really get really finite details out of it, and then modeling this with the blades and things like that are transportable. End up using a bunch of like rare earth magnets and things to hold things together while it spins around, and kind of scaling things down to the right speeds and right size was a good challenge, and it tested the capabilities of these different printers. So I took a standard wind turbine that is about the 2015 era, right? They've changed over time and they get larger and bigger, and so about the 2015 era, I made a scale model of this that actually spins. So as we set it down the tracks and we start running trains, the wind turbines start to turn, and you get that effect of the size of these next to a locomotive and next to a barn, and what they would look like in the field. And I would admit it that I've been questioned if that's actually true scale or not. And
It's huge.
it is
It
it
would
is
you really
exact.
Yeah,
It is
you
exact.
realize how big they are when you see it next to, a train or a little farmhouse or whatever was on the, diorama, so
It's actually a big draw though, and something like that as well. It's not a train, but the fact that you get a model and you get that attention to detail and it moves and it has a representation of what we see in real life. That is enough of an inspiration to bring people over to talk about it, and then the trains are like a compliment on top of that.
I've saved this to the end. I want you to talk about that pin that's on your lapel. Tell us
Okay. Yeah.
what you're involved with, and, this is pretty cool.
So I'm sure you've seen in the news that AECOM has been selected as the design, build, and program management partner for the Olympics, and my team, including myself, are involved heavily with that project out west to develop the LA 2028 games. And our company is responsible for any of the design work that's happening, the construction that's going to happen to renovate or modify venues to meet the kind of the new standard for Olympic competition, and then all the temporary structures that have to exist to be able to facilitate people and the power distribution and concessions, things like that.
I heard, I guess maybe the head of the Olympic committee out there described it as it's like having 7 Super Bowls every day for 3
Sure.
weeks, something, right?
Exactly.
But maybe
Exactly.
Matt, maybe you can just give her part of the backdrop of this is LA is not going to build any new facilities, so there's not going to be any
I heard that.
purpose-built new
Yeah.
facilities. So Matt, his team, and the AECOM team are tasked with, how many different facilities are there? 50 some? Is that what you told me?
We're up to about 60. Yeah.
60 different facilities have to be converted, sometimes converted for use, converted back, converted during the games, and then at some point converted back like within days to hand back for its normal use. So if you think about the scale, maybe you can just talk a little bit, Matt, about how you're approaching this and the scale of the problem, and the fact
Yeah.
that you got
Time's
time's
ticking.
ticking. You got to get this
Right. Countdown timer is on. I agree. Yeah, so it's unique that it's Los Angeles, right? They have everything, and they have the capacity for everything. They've hosted the Super Bowl, right? They've hosted how many major events over time, and the venues exist already for all this elite level competition, right? You're talking about football and baseball and basketball and any of the aquatic events, any of the kind of skate parks or other aspects of the Olympics. All of those exist in some capacity already in Los Angeles or vicinity of Los Angeles. So yeah, no new venues, but there are some aging infrastructure. Right, the Coliseum is one of the original big Olympic stadiums that exists. Still has a torch, right? Still has the components from the '84 Olympics. So we're looking at how do we modify that to meet the level of competition that our new and kind of contemporary athletes are exhibiting within this kind of sport. So tracks are slightly different, right? The fields are slightly different. We are repurposing venues for things that they may not originally been intended to. If you saw, I think SoFi Stadium, which is now Olympic Stadium, is going to be a swimming venue, and so we're bringing in Olympic pools and Olympic Paralympic swimming competitions.
Where do you buy those?
Are going to happen. There's a vendor for that, right? So that kind of logistics into how we plan for these venues to kind of transform for a very short period of time and then repurpose back into their existing state for the fields of play that they're meant to be is one of the challenges, one of the many challenges. Our teams have embraced this wholeheartedly and are well on pace to deliver. And it's something that is rewarding in understanding the complexity and rewarding in finding this momentum to be able to kind of transform what LA is going to look like for a few months and then bring it back to the kind of the wholesome city that we all love as Los Angeles, right? The southwest of US.
I'm curious on the transportation side, Matt, because you said LA is like well positioned, but I can't imagine they are transportation wise. So, can you comment on anything on that side?
Well, they're already exploring things in Los Angeles that help, right? They have autonomous taxi, they have rail, they have air. They're on the coast, so there's opportunities for a lot of different ways to navigate to and around Los Angeles. That's obviously something of our attention and the LA 28 committee's attention is it's projected to be the largest Olympics in the world ever, and it's projected to be the most attended by anybody to Olympics ever. So that's not going unnoticed, and it's something that is at the forefront of everybody's mind. And because there's no new venues, I think that allows us the opportunity to refocus on some of those other challenges ahead of us. Our group AECOM is really responsible for the venues and anything that's within the boundaries of the site, but we're working closely with LA 28 and the city, the state, the county, everybody to kind of help navigate that, understand what the venue impact looks like, understand what the site conditions are, and work together as a team to deliver the Olympics in 2028.
That's kind of interesting times technology-wise because obviously, autonomous vehicles and things are moving pretty quickly and starting to come into the market. So, 3 years from now, for sure, you would think that there's going to be, so it's going to make it an awkward time to plan for that. Do we plan for it?
If I could project what technology will look like in 3 years,
right,
be unstoppable, right? But
it's
not necessarily in my crystal ball right now.
But I'll bet Yeah, I mean, it's usually it's kind of like the World's Fair, right? It's a great venue for showing off new technologies and stuff. So I would
It is.
imagine with the world coming to LA in 2028 that we'll all get to see. We'll have to we'll have to make some plans, Evan, to go out and
That would be
partake
awesome.
in the 2028.
I just left LA a couple of
No,
years ago.
you just moved.
I'll be ready to go back by then.
Right.
Yeah.
Well, in complement to those challenges ahead of us, it's also rewarding to know that AECOM, in partnership with LA28, is bringing the first Olympics delivered in BIM. Right? To me, that might be a little difficult to understand that it hasn't happened yet, but it's going to be the first Olympics delivered in BIM, and we're going to be using some of those advanced tools in the way we construct and manage our activity on sites. So those are all rewarding metrics to have as part of the success story that is AECOM, LA28, and the Olympics.
I can imagine, Matt, too, with this like robotics side that you guys are doing. You said LA's got a lot of aging infrastructure. I imagine where these two things go together, right?
I can imagine they do also. I can't comment on everything, but yeah,
Sure.
there's the toolkit that we have available is certainly something that we're applying to our approach to the games.
Cool.
Specifically, Matt, tell more about what your role is and what team you're leading and
Sure. So
what you'll be doing for the
my
next
official
year.
role is a platform manager or platform director for ACC, and that's our common data environment for everything that we're doing on the games. My team and the extent of my team is supporting all of those digital delivery practices that we're using, the strategy that we're employing to deliver the games. Anybody who's involved, including our internal teams to external stakeholders all over the world, and it's something that we're kind of leveraging all the experience we've had in the history of our projects across different market sectors to come together and deliver 60 venues at the same time at the caliber of the Olympics. One of the challenges that I kind of project to my team and anybody who joins our projects is that it's an immovable schedule, right? We have a deadline that has to be met. It is something that is challenging in the complexity of all of these parallel activities that are happening on the project. And it has to be the sophistication of Olympic competition. It has to be to the caliber of worldly bests, right? And if it's not delivered to that scale, then it's not a success story. And like I said, we're well on track to deliver, and our teams are fully engaged with making that happen. So
Nice.
it's a great project, and it's I don't want to say we're just getting started because we've been working on this for quite some time with pre-planning and master planning and our teams that are doing the sports alignment with the city and all the venues. But it's years ahead, and it's a known deadline for all of us, and the anticipation is growing every day.
It'll be here before you know it.
That's great. Well, Matt, thanks for joining. I'd be remiss if I didn't say the only thing better than Mr. Matt Anderle is his wife, Katie, who also works at AECOM. But they're just a great couple. Always fun. My wife and I actually, when we went up there last month, my wife Emily went with me, and we got to have dinner with Katie and Matt and hang out and got to see Santa's Workshop in person, which for those of you that want to stick around, I'm going to try to, we'll have interspersed some of this during the conversation, but I'm going to put some extended video and photos at the end of this so people can kind of get a glimpse of what it looks like at the little workshop. Not little, it's a nice workshop up there in Columbus, Ohio.
Full of inspiration. That's how I go.
It is a lot of fun, and
Nice.
then we'll convene everybody down in Chattanooga next summer so we can see the world's largest train layout.
Absolutely, and compliments to Katie too. She's on the Olympics team with us, and is part of our platform management team. So a key personnel in delivering the games. So both of us are heavily involved and love every day of it.
Nice.
Great. Well, thanks for joining us, Matt.
Yeah, thank you.
We are in Matt Anderle's magical workshop where all of the robotics are built. Thanks for having me visit, Matt.
Thanks for visiting and welcome.
Tell me more about the fancy toys that you have here.
So this is Scout you're looking at. It's part of our robotic program we call MARCA, stands for Mobile Autonomous Reality Capture Utility Platform. A long word we shortened to MARCA. Our program consists of 5 different vehicles at this time, and it's everything from land to aquatic to aerial. And we invent, fabricate, program, and assemble everything here.
And so when you say you take these out to the field, what's their mission, or what are the different kinds of missions?
A lot of things that we're doing are inspection based and reality capturable. So this platform itself has 2 high resolution spherical cameras on it. We've got navigation cameras. We've got sensors to detect things about environmental conditions, humidity levels, temperature, the air quality concerns that you might have. And the fact that it's completely wireless, we can run it up to a mile away from us, underground, above ground, and then we can capture locally on the device and back to our operator. But we can also add on our utility trailer, which I can show you at a later time here, and put a full LiDAR scanner on the back of it and tow that behind us. Remote control everything through our robot.
So we're going to talk about your 3D printing capabilities here a little bit later, but can you kind of walk us through with this specific bot, like what parts are off the shelf, which ones are custom created? How do you
Sure.
go about that?
So, like you said, this is where the magic happens, right? Everything is designed and fabricated here in house. We use a common platform for the frame, which is this extruded aluminum profile, anything in the 20 millimeter range, so 20, 40, 20, and so on. With that, we have a lot of versatility to bracket things together, clamp things on, reconfigure if we need to for different missions. But the rest of it, everything else you see on the spot that is not a frame or a bracket, is custom designed, printed, and developed here through several iterations of prototyping. For all the light brackets we have, the bumpers, the hubs for the axles, and the drive mechanisms, the way we connect and like all those things together, all custom designed. Wired channel routing is all us. Our hub systems and trailer connection system, all that are things that we've built and customized for our platforms. And we've standardized it. So as any good developer will do, we're going to make sure that these are interchangeable between a lot of our different bots. And that way we can refine and revise and improve on a kind of a system level and then applying that to all of our different efforts.
So we're going to walk around different parts of the workshop, but even behind you, Matt, is this all the equipment that's needed to go on the road?
So not all of this goes on the road at the same time, but we've got a lot of our equipment as far as the screens and the battery packs and charging stations, toolkits and other components that complement all the services that we do in the field. And then safety code and take with us. But basically, these are a rolling workshop to go with us to make sure that we can achieve success when we're in the middle of nowhere. And that's kind of where we end up taking our rover system.
You were talking to me earlier about the use of, what are custom parts versus standard off the shelf. And you were talking about the batteries for these being off the shelf. I thought that was interesting.
So standardizing on a system and making things approachable is one of our kind of metrics for success and one of our formulas that we provide to all of our technicians and field operatives. They are built around the idea that yes, things happen on the job site and that you might have to fix a rover or change a configuration because of the conditions changing. Same with the battery packs that you're talking about. We're using standard drill batteries, something that are universally acceptable to the rover and all the other rovers that we're using, but available as well. So almost any location you're within a certain distance of a store that would sell you a drill battery that would be compatible with one of our rovers.
Yeah. So you can drop by Lowe's, Home Depot, grab a DeWalt battery and you're back off running.
Buy a new battery, charge up and take it.
Perfect.
And they're durable too, right? They've been proven at construction sites, been proven at your home workshop, wherever you're using these things. They're pretty rugged battery for it.
So let's talk about the platform over here.
So these are a couple of different configurations of our rover. Like I mentioned, we've got Scout, which is our main platform. This one's called Normal, and it is configured in a diamond shape. So it's sitting on top of a stand right now. But if you look, the wheels are turned in, and the top frame is actually like an A-frame. That's so we can get a very small diameter pipe and have this rover use the same technology and data capture that the larger units are using in a different shape and form.
And then what do we have here?
And this is our little pontoon we call Skip. That is a pretty versatile little platform. It's basically a drive propeller system, dual drive, can turn in a circle. What it do? Can hold about 4 or 5 pounds on top of it. So cameras and 360 video capture devices on there. It has some lighting system. It has its laser projection tapes that we can project onto like culverts or any kind of under bridge scenario that we're going into. But the slide rail in the middle lets us different components of different types, different equipment, and kind of create that sensor package that we need for the different missions.
What do we have here, Matt?
All right, so this is our other rover, one of our other rovers, called this one Norwal. And like I mentioned, it's kind of a diamond shape. So if you look at it from the end, it's got like a kind of square diamond shape to it. And that gets us into about a 16-inch diameter size pipe. Of course, we're not doing a lot of turning when you're in the pipe inspection, but we are getting high resolution video from front and back. They're pointed forward and backwards, kind of why it's called Norwal. It looks like the Norwal horn. Same kind of drive mechanisms. We're still using belt drives, lowered gear train, so we can get into a more tight and kind of that less traction. Like we have lower traction in some of these pipes that we get into, so we make sure we have enough torque in the device. We have to lower this down, so we kind of have these lower pins that we hook wires to, and we'll disconnect when we get to the bottom of wherever our drop inlets are. And then we have a hitch in the back. We have to tether it. Sometimes we'll tether a stainless steel cable on it just to make sure if we have to pull it back, we can, but we can also hook any of our utility trailers to this. Norwal gives us a lot of opportunity going to that tight condition, right? Certainly where people don't fit, where we can't send humans into. This device will give us that opportunity to really get inside, go long range stuff, still get into that mile long range with radio connectivity, and collecting the same kind of data package that our Scout and other rovers are collecting.
This is accessory number one for
Yeah, accessory number one. This is our utility trailer that we take behind Scout. We could hook it to Norwal if we want to, but of course Norwal is meant for a small diameter pipe. This platform is currently configured with a Leica 360 RTC 360 mount on it. So we can take one of those devices, lock it in, and then use this as its mobile tripod. It's pulled by Scout, has its own battery packs if we want to power off of our unit, and gives us a little bit more versatility to take scanners in very low clearance areas, muddy conditions, hard to reach areas, all being, of course, focused on safety for our employees, but at the same time, we're capturing all the data that Scout gives us, along with now point clouds, and can scan in as many intervals as we need to get the right data saturation.
So maybe you can show us the extension arm that you're able to carry.
Yeah, so on top of this, this right now, again, is configured for our laser scanner, but on the sides of this, we have our own robotic arm that we built to deploy targets. And often when we're trying to scan linear tubes, storm sewers, culverts, things like that, they don't have registration points. And so we built a mechanism to actually deploy those targets. And same on this frame, would run a mission with the trailer, deploy all of our targets, come back, put on the scanner, scan it, and then come back, take down all the targets. So on top of the trailer would go our robotic arm. And it's a simple 4-axis arm, right? We don't need any shoulder rotation. We have a shoulder lift mechanism, but we don't need a twist necessarily. We don't have a lot of twist rotation, but we have a twist movement. And what we're deploying then is on the other side of that trailer would be these targets. And this arm is configured in a way that we can set it to go and pick up one of these targets. It simply lifts up out of the carousel, up over, and then these are magnetic with rare earth magnets, so they stick to pretty much any metal surface. We have a deployment mechanism that's not magnetic, and this becomes our registration point then. So we deploy these about every 30 feet or so, and with this arm, we're able to see it because we have a camera on it, so we can actually watch the operation of the hand itself on a screen while we're watching the navigation of our robot, and make sure that that placement gets into a very consistent method, something that's, of course, applicable to what our reality capture devices are doing.